So now you have f of x equals 3 times absolute value of x minus 3 minus 2. So there's two tests that we have to do, but they both go hand in hand. We have to graph it and determine the transformation of, meaning how the graph changes from the original function of f of x equals absolute value of x. So basically we're trying to figure out the change from the original one. So whenever you're given something like this, of course you can make that table and go from there. But what I suggest you do is you graph out this one here before you even think about this. So the simplest function possible. The simplest function. So you have your x and the y, and I'm not going to graph that yet. I am just going to graph f of x equals absolute value. So what do these bars mean? What do these bars? They mean anything that you insert in there will result in a positive number. So it will give you a positive. It's the distance from 0. So your distance is always going to be positive. So as usual, we're going to start at negative 2. So if you plug in a negative 2 in here, what's the absolute value of negative 2? Yes, it's positive 2. Good. Good job. Negative 1, 1, 0, 0, 1, 1, 2. Of course, absolute value of 2 will be 2. So notice, when you plugged in a negative 2, you got a positive 2. And negative 1, positive 1. 1, still the same answer. So I want all of these y's for this one, this function, to always be positive. So let's graph that out. Negative 2 is going to give you positive 2 here. Negative 1 is going to give you positive 1. 0 is 0, 0. 1, 1, and blah. Now let's connect. And I want to do it in a different color so you guys are able to see the change. I will use green. I hope nobody is green blind. Okay. So let's go this way. That. And there you go. Oh, that is the ugliest error ever. Alright, here you go. So now, let's look at the transformation. Remember with the x's, when you have x minus something, it's the opposite. It's the opposite of what you think. So your graph is not going to be shifted 3 units to the left. It will be shifted 3 units to the right. So what we do is this, let's make this point here as our reference point. So this guy is going to jump how many units? One of those 3 units to the right, and so now he's here, but he's also going to go 2 units down. So that's where this guy from here, it goes all the way down here. Why? Because 3 units to the right and 2 units downstairs. All right, so that's where we lie right now. Now, what do you think this 3 on the outside, what will that do? So if you had, let's say, y equals x. If you multiply that by 3, so you had y equals 3x, your graph would become skinnier, or it would get closer and closer to 0. So I should graph that out just to show you guys how that would change things for you. You see, y equals x, a linear graph. You all remember what that would look like, right? I'm just going to give you a rough graph before I do that. All right, so y equals x, 1, 1, 2, 2. That would look like so. Well, y equals 3x would be 1 and 3 over here. So that would look like this. This right here is y equals 3x. This right here is y equals x. So here, because of that 3, your graph will become skinnier. Alright? So I'm not going to be able to graph exactly what it's going to be because it's humanly impossible. So I will just give you a rough estimate of what that would look like. So the graph would get skinnier as it goes this way. Alright, so do you see? This graph is so much skinnier, should be 3 times skinnier than this guy. So the green guy, big fat guy, the red guy, skinny, because of that 3. Alright, and that's it.